Morning everyone. I am Christal Anand, Assistant Professor, Department of Information Technology, PLTech Multitech, Dr. Rangarajan, Dr. Soundala Engineering College. Today I am going to talk about fundamentals of web application security. So the history of software security. The history of software security is a story of adapting to new technologies and the evolving landscape of threats. Initially, security was simpler, focused on securing individual machines. The rise of networks and the internet created a more complex environment, necessitating more sophisticated security measures. From early access controls on mainframes to the development of commercial security software and the ongoing battle against malware, software security has constantly evolved to meet new challenges. So, evaluation timeline. In 1960s to 1970s, the beginning of computer networks and the first cyber attack happened. Second, in 1980s, the first firewall technologies developed, allowing organizations to control access to their computer networks. Third, in 1990s, the rise of the internet, increased use of computer networks led to the increase of cyber attacks. And fourth, in 2000s, advent of World Wide Web, which led to significant increase in the number of cyber attacks. Fifth one, 2010, advanced tactics such as phishing, spear phishing, and ransomware to steal sensitive information and extort money from their victims. Sixth one, 2020's dramatic increase in the use of video conferencing, collaboration tools, and cloud-based services which can be exploited by cyber criminals during the COVID-19 spread. Today, the development of advanced technologies such as artificial intelligence playing a major role in the fight against cyber threat. So, it is potential cybersecurity using artificial intelligence. So, web application security threats. So, recognizing web application security threats involve understanding common vulnerabilities and attack vectors that can compromise the confidentiality, integrity, and availability of web applications and their data. This threat can lead to data breaches, financial losses, reputational damage, and legal penalties. By identifying and mitigating this risk, organizations can protect their web applications and users from malicious attacks. So, first one, injection attacks. A web application that is vulnerable to injection attacks accepts untrusted data from an input field without any proper sanitation. By typing code into an input field, that attacker can trick the server into interpreting it as a system command and thereby act as the attacker intended. How to prevent? Keep untrusted input away from the commands and queries. Use a safe application programming interface that avoid interpreters or uses parameterized interfaces. Filter and sanitize all input as per a whitelist. This prevents the use of malicious character combinations. Second one, broken authentication. Broken authentication is an umbrella term given to vulnerabilities wherein authentication and session management tokens are inadequately implemented. This improper implementation allows hackers to make claims over a legitimate user's identity, access their sensitive data, and potentially exploit the designated ID privileges. How to prevent? End sessions after a certain period of inactivity. Invalidate a session ID as soon as the session ends. Place limiters on the simplicity of passwords. Implement multi-factor authentications. Third one, cross-site scripting (XSS). It is an injection-based client-side attack. At its core, this attack involves injecting malicious code in a website application to execute them in the victim's browser eventually. Any application that doesn't validate untrusted data adequately is vulnerable to such attacks. So, how to prevent? Encode all user supplied data. User auto sanitation libraries such as OWASP and whitelist inputs to disallow certain special character combinations. Fourth one, insecure direct object references. Mostly through manipulation of the URL, an attacker gains access to database items belongs to other user. For instance, the reference to a database object is exposed in the URL. How to prevent? So implement proper user authorization. Check at relevant stages of user's web journey. Customize error messages so that they don't reveal critical information about the respective users. Try not to disclose reference to object in the URL. Use post-based information transmission over GET. Fifth one, security misconfigurations. This is the most common web application security threat found across web applications. This vulnerability exists because developers and administrators forget to change some default settings such as default passwords, usernames, reference IDs, error messages, etc. So how to prevent? Frequently maintain and update all web applications components, firewalls, operating system, server, databases, extensions, etc. Make sure to change default configurations. Make time for regular penetration tests. Through this applies to every vulnerability that a web app would have. Sixth one, unvalidated redirect and forwards. Pretty much every website redirect a user to other web pages. When the credibility of this redirection is not accessed, the website leaves itself vulnerable to such URL-based attacks. A malicious actor can redirect user to phishing sites or sites containing malware. This is search for this vulnerability extensively since it makes it easier for them to gain user trust. How to prevent? Avoid redirection where possible. Give the destination parameter a mapping value rather than the actual URL. Let the server-side code translate the mapping value to the actual URL. Missing function level access control. The seventh web application security threats in this list is mostly similar to IDOR. The core differentiating factor between the two is that IDOR tends to give the attacker access to information in the database. How to prevent? Implement adequate authorization measures at relevant stages of users' web app use. Deny all access to set features and functions unless attempted by a pre-approved user. Allow for a flexible shift in grant and a rejection of access to features privileges in your code. Hence, allowing a practical and secure shift in privilege access when needed. Next one, web application security. So web application security is the process of protecting websites and online services against different security threats that exploit vulnerabilities in an application's code. Common target for web application attacks are content management system, data administration tools, and other SaaS applications. Web application vulnerabilities. So web application vulnerabilities are typically the result of a lack of input and output sanitation. output sanitization. Such vulnerabilities enable the use of different attack vectors, including SQL injection, cross-site scripting, remote file inclusion, cross-site request forgery. Web application security solutions and enforce security procedures such as PCI Data Security Standard certification should be deployed to avoid such threats. So web application firewalls are hardware and software solutions used for protection from application security threats. These solutions are designed to examine incoming traffic to block attack attempt, thereby compensating for any code sanitization deficiencies. Web application security checklist, information gathering. So manually review the application, identify entry points and client-side codes. Classify third-party hosted content. Authorization. Test the application for path traversal, vertical and horizontal access control issues, missing authorization and insecure direct object references. Cryptography. Secure all data transmissions. Has specific data been encrypted? Have weak algorithms been used? Do randomness error exist? Denial of service. Improve an application's resilience against denial of service threats by testing for anti-automation, account lockout, HTTP protocol, DOS, and SQL wildcard DOS. Authentication and authorization. Authentication and authorization are two different but related security processes. Authentication verify a user identity, while authorization determine what resource a user can access after authentication. They are both crucial for securing systems and applications. Authentication is the process of confirming that users are who they claim to be. It involves verifying user credentials like username and passwords, or using multi-factor authentications methods like biometric or one-time codes. So think of it as a showing your ID to get into the building. Authorizations. So that determine what a user is allowed to do within a system after they have been authenticated. It defines access levels and the permissions based on roles, attributes, or rules. For example, a user might be authenticated as an employee but only be authorized to access specific files and applications related to their job. Next one, secure socket layer. Secure socket layer is a security protocol that establishes an encrypted link between a web server and a browser, ensuring secure transmission of data between two. It is a crucial technology for protecting sensitive information exchanged online, preventing eavesdropping and tampering by third parties. SSL is widely used to secure websites, particularly those handling sensitive user data like login credential, financial information, or personal details. So SSL means secure socket layer, and it is a cryptographic protocol that provides secure communication between the browser and the server of the website. All data that passes is encrypted and private. Working of SSL encryption. SSL encrypts data transmitted over the web, ensuring privacy If someone intercepts the data, they will see only a jumble of characters that is nearly impossible to decode. Authentication. SSL start an authentication process called a handshake between two devices to confirm their identities, making sure both parties are who they claim to be. Data integrity. SSL digitally signs data to ensure it has not been tampered with, verifying that the data received is exactly what was sent by the sender. Secure socket layer protocols. There are different protocols are there: SSL record protocol, handshake protocols, change cyberspec protocol, RR protocol. SSL record provided two services to SSL connection: confidentiality, message integrity. In the SSL record, protocol application data is divided into fragments. The fragment is comprised and then encrypted MAC generated by algorithm like MAC means message authentication code generated by algorithms like secure hash protocol and MDH. After the encryption of the data is done and in last SSL header is appended to the data. Handshake protocol. Handshake protocol is used to establish sessions. This protocol allows the client and the server to authenticate each other by sending a series of messages. So handshake protocol uses 4 phases to complete its cycle. Phase 1, both client and server send hello packets to each other. In this IP session, the protocol version are exchanged for security purpose. Phase 2, server send its certificate and a server key exchange. The server sending the server hello and packets. Phase 3, in this phase, client reply to the server by sending it certificate and client exchange key. Phase 4, change cyberspec occur, and after this is the handshake protocol ends. This is the architecture of SSL handshake protocol. There is a client and server. Client send the hello message to the server. That is the phase 1. It is establishing the connection. Then server send to the hello message to the client. Then server send the certificate. Server request client certificate server key exchange happening. And client send certificate and client key exchanging the key for client authentication. Then change the cyberspec handshake finished between the client and server. The first protocol is change cyber protocol. This protocol uses the SSL record protocol. Unless handshake protocol is completed, the SSL record output will be in a pending state. After the handshake protocol, the pending state is converted into the current state. Change cyber protocol consists of a single message which is 1 byte in length and can have only one value. The protocol purpose is to cause the pending state to be copied into the current state. So alert protocol. This protocol is used to convey SSL related alert to the peer entity, which message in this protocol contains 2 bytes. Silent features of secure socket layer. The advantage of this approach is that the service can be tailored that the specific needs of the given application. SSL was originated by Netscape. SSL is designed to make use of TCP, to provide reliable end-to-end secure service. This is a two-layered protocol. Then transport layer security. Transport layer security is a cryptography protocol designed to provide secure communication over a computer network, primarily used to encrypt data transmitted over the internet. It is the successor to secure socket layer and is widely used in applications like web browsing, email, messaging, and voice over IP. TLS ensure confidentiality, data integrity, and authentication of the communicating parties. So this is the architecture of TSL. So in this architecture, a secure encrypted connection is established. Client sending the hello message to the server sending the key to the client, and the client exchange the key and finish that connection. So automatically the secure encrypted connection is established between the client and the web server. This is the one of the example of handshake protocol in the TLS. There are several benefits of TLS encryption. So TLS or SSL can help to secure transmitted data using encryption. Interoperability. TLS or SSL work with the most web browsers including Microsoft Internet Explorer and on most operating systems and web server. Algorithm flexibility. It provides operations for authentication mechanism, encryption algorithm, and hashing algorithm that are used during the secure session. Ease of deployment. Many applications TLS or SSL temporarily on a Windows Server 2003 operating systems. Easy of use because we implement TLS or SSL. The applications layer, most of its operations are completely invisible to clients. Session management. Session management is the process of maintaining and controlling sessions in a system, particularly in web applications. It involves tracking user activity, managing user authentications, and ensuring secure interactions throughout a user session. What is a session? A session is a semi-permanent interactive information interchange between two or more communicating devices. In web applications, a session is initiated when a user logs in and continues until they log out or their session expires. Components of session management. Session ID, a unique identifier assigned to a session, typically stored in a cookie, URL parameter, or hidden form field. Session storage, where the session data is stored, server-side memory, database, cache, etc. Should be protected from the unauthorized access. Session lifecycle, creation and usage and expiry or destruction. Input validation. So input validation is the process of verifying that data entered by a user or received from an external source meet the expected format, type, and constraints before it processed by a system. It is a crucial security measures to prevent errors, system malfunctions, and attack like SQL injections or cross-site scripting. Why is input validation important? Security. Protect against various attacks including SQL injection, cross-site scripting, and other malicious input. Functionality: prevent errors and system crashes by ensuring data is processed correctly. User experience: provide immediate feedback to users if their input is invalid, improving the overall user experience. Key aspect of input validation: data type validation. Ensure the input is of the correct data type. Format validation. Check if the input follows a specific pattern. Range validation. Verify that the input value falls within an acceptable range. Required field. Confirm that mandatory fields are not left blank. Thank you.